Sathyabama Institute of Science and Technology.
Myself, Dr. P. Ajitha, Professor, School of Computing, Sathyabama Institute of Science and Technology, Chennai. So, in this session, let us see about one of the minimum spanning tree algorithm, Prim's algorithm. So, before going to the Prim's algorithm, let us see some of the basic concept in that. First, let us see what is graph. Graph is a collection of nodes and edges. So, graph we can represent as capital G is equal to capital V, comma, capital E, where capital V represents set of nodes and capital E represents set of edges. So, here we are representing two types of graph. One is directed, another one is undirected graph. So, the difference between directed and undirected graph is, in the case of directed graph, the edges will be having arc. Okay, so this is about your graph. So, now let us see what is network. If the graph edge are having weight, then the graph can be called as network. Now, we will see what is spanning tree. Spanning tree is the one that we will be constructing from the graph. So, in the case of spanning tree, all the nodes present in the graph should be there, as well as the number of edges should be number of nodes minus 1. So, here we are having a graph. The graph is having 3 nodes and 3 edges. So, from that graph we are going to construct the spanning tree. The number of spanning tree we can construct from the graph depends on the number of nodes. Take for example, if you are having n nodes, we can have n power n minus 2 spanning tree. So, in this diagram, the graph is having 3 nodes. So, 3 power 3 minus 2 is equal to 3. So, totally we can construct 3 spanning tree. So, the spanning tree should have all the nodes present in the graph plus the number of edges should be n minus 1, where n represent number of nodes. Okay, since it's a tree, tree should not have a cycle. So, here we are having 3 spanning tree. Out of this 3 spanning tree, one will be called as a minimum spanning tree. So, the condition for minimum spanning tree is same as minimum spanning tree. Every node must be in the spanning tree from the graph. Number of edges should be n minus 1. There should not be no cycle. So, the main criteria in the case of minimum spanning tree is overall edge weight cost should be minimum. So, if that is the case, then that is called as minimum spanning tree. So, minimum spanning tree should have all the nodes present in your graph plus number of edges should be n minus 1 and total edge cost should be minimum. That criteria has been satisfied means then the spanning tree will be called as minimum spanning tree. The application of this minimum spanning tree is, if a salesperson is there, if you want to visit all the cities with minimum cost or minimum distance, you can go for this minimum spanning tree algorithm. Okay, so we are having various minimum spanning tree algorithm. In this session, we are going to see about Prim's algorithm. So, this is the network we have taken. So, why this is called as network is, so this is a graph. So, if you see the edges are having some weight. If the edges are having weight, then it is called as a network. Assume we are having totally 7 cities. Each node represents the city. The salesperson, you want to visit all the cities with minimum cost or distance. Okay. So, the edge weight we can represent either as cost or distance. So, here we will consider as cost. Okay. From this network, we have to frame the minimum spanning tree using Prim's algorithm. So, if you see the Prim's algorithm we can have 2 phases. In the first phase, we have to follow few steps, and in second phase, we have to follow an iterative procedure. First, we will see about the first phase steps. Okay, the first step in the first phase is we have to construct a cost matrix. Okay, how to construct the cost matrix for the given network? This is your network. First, identify number of nodes present in the network. The number of nodes present in this network is 7. Since we are having 7 nodes in our network, the cost matrix will have 7 rows and 7 columns. That is, the number of rows and columns depends on number of nodes present in our network. Since 7 rows or 7 columns are there, we have to fill the entry. So, how we can fill the entry? See here, the diagonal values are 0 because the distance or cost from 1 to 1 will be 0. The distance from 2 to will be 0, or distance to cost to travel from 3 to 3 is 0. So, diagonal values fill 0. Now, take the first node. Okay, first row represent the first node. So what are the nodes directly connected with 1? That we have to see. So with node 1, 2 is directly connected and 6 is directly connected. So now we know the cost from 1 to 2 it is 28. So make the entry in the cell 1 to 2 as 28 and 1 to 6 we know the cost is 10 and 1 to 6 make the entry in the first row as 10. First row is only direct connection we are having 2 and 6, that entry we have entered. So 1 is not having direct connection with the remaining nodes. So for the remaining nodes the entry in the cost matrix should be infinite. That is 1 to 3 it is infinite, 1 to 4 infinite, 1 to 5 infinite, 1 to 7 infinite. So if the node is having direct connection then put the entry in the cost matrix. If not the entry will be infinite. Same procedure for node 2. So second row represent node 2. So node 2 is having direct connection with 1, direct connection with 3, direct connection with 7. So from 2 to 1 the cost is 28, from 2 to 3 the cost is 16, from 2 to 7 the cost is 14. So that entry we are filling in the cost matrix. So node 2 is having direct connection with 2 to 1, 2 to 7 and 2 to 3. So remaining entries in that row we have to mark as infinite. Same procedure we have to follow for the remaining nodes. So if we follow the same procedure for all the 7 nodes, we will be getting the cost matrix. Okay, the first step you have to do is to construct the cost matrix. So now we will go for step 2. Step 1 is cost matrix construction. Step 2 what we have to do is we have to design the T matrix. So number of rows in the T matrix should be n minus 1. Okay. So n minus 1 rows will be there. We have to put the first entry in the T matrix. To put the first entry in the T matrix, find out the least cost edge in your network. The least cost edge in the network is 10. So the node connecting 10 is 1 and 6. So 1 and 6 we are entering into the T matrix. So after entering 1 and 6, we have to construct the near array. The number of rows in the near array represent number of nodes. So this is a single dimensional array. Since it is a single dimensional array, only one entry you will be having in your array. So in this near array, what we are going to do is, we are going to check node 1 is near to 1 or near to 6. If node 1 is near to 1, the entry in our near array will be 1. Otherwise, the entry will be 6. So like that, you will be filling the near array. So using this statements, we will be filling the near array. That is our third step. So once we fill the near array, since 1 and 6 got entry in the T matrix, we have to make the entry for 1 and 6 in the near array as 0. So we have to make the entry of 1 and 6 as 0. After making that entry as 0, find out what is the cost for the remaining nodes. So 2 to 1 the cost is 28, 3 to 1 the cost is infinite, 4 to 1 the cost is infinite, 5 to 6 the cost is 26, 7 to 1 the cost is infinite. So out of this you have to find out which one is having minimum cost. So the one which is having minimum cost is 5, 6 which is 26. So this is the second entry in our T matrix. Now 5, 6 got entered into the T matrix. So these are the steps we need to follow for phase 1. In the case of phase 1, first cost matrix construction. Second, we have to create the T matrix and fill the first entry in the T matrix. Third, we have to construct the near array. And fourth one, we have to find out the minimum cost and that will be entered into our T matrix. So this is phase 1. Phase 1 is over. Now we have to go for phase 2. Phase 2 is going to follow a procedure, iterative procedure in order to fill the remaining entries in our T matrix. Okay. So this is our near array. So for 1 and 6, the entry is 0 because already 1 and 6 got entry in the T matrix. Now 5 and 6 got entry into the T matrix. So what we have to do is for 5, the near array we have to make a 0. So whenever the near array values are 0, we no need to bother. Okay. So for the remaining things, what we have to do, already what is the cost to travel from 2 to 1? It is 28. Now we have to consider the new entry in the T matrix which is 5 as j. So 5j is equal to 5. Cost of 2, 1 is 28. What is the cost of 2, 5? That we need to find out. So 2, 5 the cost is infinite. So the previous one is better. Similarly, 3, 1 is infinite. Compare 3, 5. 3, 5 is infinite. That is better. 4, 1 is infinite. But 4, 5 if you see the cost is 22. Since 4, 5 is lesser, we need to update the near array. Instead of 1, it should become 5. Similarly, for 7 also we need to check. 7 to 1, the cost is infinite. But 7 to 5, the cost is what? 24. That is lesser. So, like that, we have to apply for all the array entries. So, once you completed, find out which one is minimum. So, the minimum here is 22. That is node connecting 4 and 5. So, the next entry in the T matrix is 4 and 5. Now, 4 is a new entry. So, for 4, we have to make a 0 and j is equal to 4. Apply the same procedure. 2, 1, it is 28. What is 2, 4? 2, 4 is also infinite. That is better. Similarly, 3, 1 is infinite. 3, 4, what is the value? 12. So, 12 is lesser. Update as 12. So, remaining 0 entries, don't need to bother. Finally, 7, 5 is 24. 7, 4, if you see 18. 18 is lesser. Put entry. Out of this, which one is minimum? 12 is minimum. So, node connecting, that is 3, 4, put the entry. Like this, we have to follow for the remaining things till we complete our T matrix, as well as the near array value will be 0. So, once we constructed the T matrix, we got the list of edges which we have to use to construct the minimum spanning tree. So, using that, we are constructing the minimum spanning tree, and the final minimum spanning tree is we have to travel from 1 to 6, then 6 to 5, 5 to 4, 4 to 3, 3 to 2, 2 to 7. Either this path the salesperson can follow, or 7 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 1. So, using any one of this path, he can cover all the cities. So, this is the algorithm for that, the same steps which we have followed. First, we have to construct the cost matrix, then least cost edge, 1, 6 we have selected. So, that we are entering into the T matrix. After entering that, we are constructing the near array. So, if L is near, the entry will be L or it may be K. So, once you created the near array, we have to make the entry of K and L as 0. So, after making this as 0, we are going to find out the edge J. So, after finding the edge, we have to compare the cost. That is near of J not equal to 0. 0 entry, no need to bother. For the remaining things, you are doing the comparison. After doing the comparison, we are entering the entire T matrix. So, once you got the T matrix, we got the edges that we need to use for constructing the minimum spanning tree. So, this is the algorithm used for constructing the minimum spanning tree. Thank you.